Okay guys, we're going to look at 1272. In this problem, again, we're doing erratic motion. How do we know it's an erratic motion problem? It's given in this type of form where the motion is not a continuous function. It's a piecewise function. Okay? So, it says here the VS graph. Alright, the VS graph. So now, we don't have a VT graph. We don't have V as a function of time. We have V as a function of position. So the VS graph for an aeroplane is traveling down a straight runway. Determine the acceleration of the plane as s equals 100 and s equals 150. Okay? Draw the AS graph. So here we have the VS graph from 0 to 100 meters. So now guys, take note, this is not time, hey? This is position. So from 0 to 100, we have this function, and V is a function of position now, not time. And from 100 to 200, we have this function. Both these linear functions, V is 0.1s plus 30, right? So we have now, here's that function, 100, and there's 200. This is V is 0.4s, V equals 0.1s plus 30. Okay, so guys, V is a function of position now, not time. So, and they want us to essentially, let's calculate the AS or draw the AS graph. How are we going to do that? Well, we need to go here to page 21. Okay, so we're very used to, if we have V as a function of time, calculating A as a function of time, or calculating position as a function of time. So we're very used to working with the time graphs. But now we've got position, the V as a function of position graph, and we want A as a function of position, or the AS graph. Okay? So I just want you to take note of this and go and review it. This is page 21, the VS and AS graphs. If we have an AS graph, and we want a VS graph, we need to do this lovely thing there. Okay? You need to go have a look at this. Okay? So this is if we have the AS graph, we're trying to find the VS graph. I'm not going to describe this now because we're not doing that. But so this is to get the VS from the AS. We want to calculate the AS from VS. That's this problem. And essentially, what do? Where does this come from? We know ADS equals VdV. ADS equals VdV. And if we try to calculate acceleration from that equation, ADS equals VdV, we will get this. So we take ADS equals VdV. We know that our acceleration is V times dV ds. That is our acceleration. So if we have a V as a function of s, or a VS graph, then we know if we're trying to find the A acceleration, which will be an AS graph, we need to use this rearrangement of that fundamental equation, ADS equals VdV. So A is equal to V times dV ds. Okay? So, yes, that's okay for now. So go and have a look at this. This is on page 21. Okay, so, but again, so this is the fundamental equation that we're going to use. But again, the procedure is exactly the same as what we've done before. We break it up. Now it's not time, it's position. So it's between 100 meters and 0. What is our function? Our function is V is 0.4s. Let me just get it again. This is a problem 1272. So we're looking for A, which is V times dV ds. So what is V? It is this, 0.4s. And what is dVds? What is dVds of this? It's just 0.4. So we are going to have 0.16s. There is our function. So we had v as a function of position. Now we have a as a function of position. Okay? Hope you guys are happy with that. So now we've got our function, but now let us look at what is happening at 0 and 100. Remember what I always tell you guys to do is to get the function. So what is a? What is the acceleration at position is equal to 0? A is 0. And then at position equals 100 for this function. Okay, this is an A equals, if I put 100 into there, A equals 16 meters per second squared. Great. Good stuff. So we've got our function and we've got our two extreme values. Now let's look at between 200 and 100. What is my velocity function? It is 0.1 s plus 30. So A is v dv ds, which is 0.1 s plus 30. That's the v, right? Then what is dv ds? It is just 0.1. Remember, we're taking dv ds. We are differentiating the velocity function with respect to position now. That's the variable, dv ds. And this gives us 0.01 s plus 3. So that is the function. That is my as function between those positions. That is my as function between those positions. So let us try and so there's our function. Now let us try and look at the extreme ends. So what at s equals 100. Okay, remember that's my extreme points. That's my beginning point is 100. That's my ending point, 200. At s equals 100, acceleration equals, I put a 100 into there, that becomes 1 plus 3. So I plug 100 into there. 100 times 0.01 gives me 1 plus 3 is 4. So at s equals 100, my acceleration is 4. Okay? At s equals 200, my acceleration, if you put that into there, will give me 2 plus 3 is 5. Okay? So now we can take this information. There is our acceleration and there is our position. And between 100 and there's 200, we can draw it. So there is my function during the first period, and that looks like this. It's a linear function. Its acceleration is 0.1 times s, and the value there at 100 is 16. Okay, now you'll notice this is quite interesting. This function is given by 0.01 s plus 3, but what are my limit values? At s equals 100, I have an acceleration of 4. So if there is 4, that's where we start. Our new function starts there. So you can see there's this discontinuity. And it's a linear function. It's linear. And at s equals 200, it is 5. So it moves up like this to 5. Okay, so this is not to scale, but don't worry, you get the idea. Okay, so there is the second one. A equals 0.01 s plus 3. Okay, so the question was, determine the acceleration of the plane at s equals 100. That's actually quite an interesting problem. I never thought about it till now. But we've got 16 meters per second. So I guess the answer is 60 meters per second, although you've got this discontinuity. Okay? And then what is it at s equals 150? So at s equals 150, so the question is, what is acceleration at s equals 150 meters? So now we have this function here. Where's 150? It's over there. Where is this function? What function governs this over this period? It's this. So all I need to do is put 150 into there. And we get 150 times 0.01 plus 3. And it equals 4.5 meters per second squared. Okay? And then you have to ask yourself, does that make sense? Yes, it makes sense. At s equals 100, I have 4. And at s equals 200, I have 5. And this is 4.5, so it fits perfectly in there. 4.5. Okay? All right, hope this helped. Good luck. Cheers.